laziness. So laziness, if you know Python 2, you know that Python 2 would have range and X range. And X range would be extremely the Python 2 X range would return a list, whereas X range would return a generator. And what a generator does, it gives you one element at a time. So let me exemplify this with Python 3 to make the case. We are going to get the size, and with Python 3, by the way, Python 2 is eager in the sense that it tries to render everything, and that is a disaster for our needs. But Python 3 tends to be lazy, so it doesn't return lists or sets. Many functions return generators, iterators, whatever, but they don't realize the whole object. So for example, this is Python 3, and Python 3 range is now an iterator. And if you get the size of it, so this line here is the size of a range of 1,000,000 or whatever is there, and the size is 48 bytes. Because if you do this, it's not a list. This one, the type would be a list. It's a class range, which is essentially a generator. And that means that the lazy functions, they don't execute, so they don't take time to generate, and they don't occupy a lot of memory. Whereas if you are eager, that is the old Python, if you do this, the memory occupied by this is 8 kilobytes, 80 megabytes. Okay, and you might think, okay, Python does all that for me. Not really, because now you have to think when you need to use return lists or return generators. And you might think, but sooner, first of all, you have two advantages here. Well, there are three things you need to consider. So if you have a generator, it's trivial to convert it to a list. You just do list blah blah, and you have a list. So you can go from a generator to a list, but not vice versa, in operational terms at least. In conceptual terms you could, but what would be the point? Instead of returning a list, you can return a generator, and you have three advantages. First, the generator can be trivially converted to a list, so you lose nothing. You have the memory advantage, and you might or might not have the compute advantage. Imagine that you are trying to search for element 550. Imagine that you are trying to search for element 550 or whatever. You just have to see if it is there. If you have a generator, you don't need to execute everything. So it's not just the memory. It's not just the memory gain, but if you don't need to realize the whole computation for some reason, because you can stop at the middle, then all that computation that a eager list needs doesn't need to be executed, and that allows for pipelining. So, for instance, if with lists you do something like function 1, let me take down of, say, big data. So, and you are interested in the first element, or say the 10th element of this. If you do, and imagine that big data has 1,000,000 elements. If these things are functions, i.e. they return lists, this function will, before function 1 is executed, function 2 will have to execute, do all its work on top of all the data, and it will require whatever memory it's needed, and it will do all the computation. Function 1 will then be applied to all the results and do all the computation, and then this function would get the 10th element of this, which with a list you could actually do this, right? But actually with a generator you can't. With a generator you'd have to do next over it, essentially, because you are essentially asking for the execution. But if you do this with generators, what 10th does is, okay, I need the 10th element, function 1, give me the first. And function 1 would go to function 2 and say, function 2, give me the first. And the first one would be yielded to function 1, and function 1 would require as many as needed from function 2. It can be more than one, depending what function 1 is doing. And it would do this for the first, for the second, and until the 10th. And at the 10th, everything could stop. So if for some reason all of this was linear on the inputs, and this was a size of 10 million, instead of doing the computation for 10 million elements 2 times with all the memory, you would essentially only compute until element 10. And I would strongly recommend, my suggestion is always try to write a generator and do yield and yield from. And always try to do yield. And if it doesn't, if you are doing data engineering, the default should be yield and should be laziness, unless you think that you really need to be eager. And that is a general suggestion here.